Welcome back to the channel. Today we're going to take a look at how to deploy CML2 labs with Terraform. And this all kind of started whenever I read this blog post by Ralph Schmitter. Definitely botched the last name. Apologize, Ralph. It was a great blog post back in December where he actually built a Terraform provider to deploy labs, virtual network labs in Cisco Modeling Labs too. So I'm going to quickly go over kind of each of those components, CML and Terraform, their purpose, and then we're actually going to take a look at some code and some Terraform code of actually deploying labs in CML. So CML, if you've been watching any of my live streams or looked at my YouTube channel, I pretty much only exclusively use CML now. I did use EvenG in the past, but I've really enjoyed using CML, and it kind of has fit my use cases. So you can see here, this won't be a super deep dive into CML, but essentially you build virtual network topologies where you can test and try out new things on a virtual network, an isolated network. You can connect it back to what CML would call an external network, or back to your home network, or if you have this deployed in an enterprise, you can connect it back to your enterprise network. But these are meant to be kind of isolated and really just labs that you can configure, destroy, whatever you'd like to do. So where Terraform fits into this is Terraform. And I'm actually going to switch over to the Terraform docs that go over the CML2 provider. So Terraform is kind of one of the base tools of infrastructure as code. It's used to provision resources. So some have may heard of Ansible. Ansible actually works really good with Terraform. It's not necessarily a competitor. They do have some overlap in some spaces, but essentially think of Terraform as a tool that can deploy your resources, such as virtual machines, any cloud resources, so anything AWS, Azure, GCP, but kind of think of it from that standpoint. And then Ansible kind of comes in afterwards and can do that configuration management, deploying, configuring any software dependencies, updating any packages, that sort of thing. So obviously, you can use these tools in any way you see fit, but I like to give a very basic example before I dive in. So I use the word provider. Provider essentially think of it as almost packages that know how to translate Terraform code, because Terraform, as I mentioned, is a infrastructure as code tool, so it's very abstract, has kind of an abstraction layer. So these providers know how to translate that abstraction into something that, the lower level code per se. In this case, CML, the CML2 provider, actually utilizes the REST API that's available with CML. So here, it shows a basic example. This is the CML2 provider documentation, and I'll actually go through that in the demo code. So before I go any further, all this code will be on my GitHub account. Right now, you might notice it says private, but I will be making this repository public once this video is published. So let's start here with CML. So you can see I have multiple labs that are configured that I've done with the DevNet Expert studies, Postman, just some practice. Basically, what CML will allow us to do is we can define the lab in our Terraform configuration files, and it will deploy it and actually turn it up. And so basically power on the devices, and even get them configured. So let's jump over to the code real quick, and you'll see right here I have two folders. So it's very important. And like I said, I don't want to dive too deep into Terraform, because that is its own separate topic. And I want to keep this video kind of very focused to Terraform and CML2. So you want to make sure that each all your code is separated into different folders and view them as separate projects. Essentially, Terraform sees each folder as its own project, so you don't want to kind of have multiple Terraform files in the same folder if they're used for different purposes. And hopefully I can show that with this small example. So there are two ways to deploy or define your labs within Terraform. And this is actually some terminology I got from the blog post. So if you're interested in this, I'll also have a link to the blog post in the description, in the video description. But there's a define mode and an import mode. So as I mentioned with the CML2 provider, and let me jump back to the documentation real quick, we have this concept of resources. So these resources are kind of exactly what it says, right? Specific pieces that you can deploy, using the provider. So in this case, you can deploy what is considered a lab resource. So some basic things like a title, the description of the lab, and maybe some notes. And then I'll just kind of jump between the ones that make sense. The node resource is kind of that exactly what you think. It's that network device, that virtual network device that you'll be putting into your lab. And there's specific things you could put in here. There's required attributes, and then there's also a bunch of optional as well. Links, pretty straightforward. Those are the links that connect each of the nodes. And then CML2 lifecycle. This is actually one of the most important resources. This is what controls and manages your turning your lab on and off. That's kind of a big piece of it. But as they mentioned here, it's really the glue between all the different resources. So you define a lab, you define the nodes, you define the links, and then at the end of it, the CML2 lifecycle resource then kind of puts it all together for you, and can, like I mentioned, start the lab, stop the lab. I'm trying to find the example here. Yeah, so here's the example resource, and you can see you have a lab ID, you have your different elements, so you have your different nodes and your different links, and then you have something called staging, which we'll get into in the example. So hopefully that was a decent run through of resources. Like I said, if all this terminology is kind of freaking you out, hopefully I'm at least providing a way for you to, it helps translate kind of where we're going. So let's jump over to the code, and we'll start with the define mode. So the define mode is very verbose. That's the best way I like to describe it. So this is where you define those individual resources that we just went through. So you'll define a lab, you'll define the different nodes, you'll define the link, or the links, I'm sorry, between the different nodes, and then finally your lifecycle resource will bring it all together and start the lab. So I'm gonna go ahead and spin this up. So for those that aren't familiar with Terraform, I actually would recommend that you check out a few basic videos, Terraform basic videos, to where you can run through like, what is Terraform, why is it used, before you dive into this. But I think this will help provide, like I said, it's a high level of overview of Terraform and using it with CML2. So if you're interested in Terraform, definitely recommend checking out the documentation and other videos as well. So Terraform is a declarative tool, and so basically you define what you want your infrastructure to look like, and then you deploy it using these configuration files. And in this case, main.tf is that configuration file. So what we'll do is use, there's kind of a three-step process. You use Terraform plan to show what changes in the environment based on what's deployed and what you have in your configuration file. So we'll quickly see what is going to be deployed when we run this main.tf file. So I have and I didn't really mention it, but I do have a secrets file that's mostly used for, obviously, secrets, username, password, and even like the IP address of your CML instance. But you can see here, there's a lab that will be created, a lifecycle, using the lifecycle resource will be created, And it kind of, like I said, just goes through and says every little resource that will be deployed in the environment. Now, I don't have this currently deployed, so everything's going to show as plus, and there won't be any minuses. So we'll go ahead and run Terraform apply. And we'll use that var file again. Like I mentioned, that just holds those sensitive variables, so that way I'm not putting them in the video. So it shows the Terraform plan again, and then it says, do you actually want to perform these actions? We'll say yes. And it's going to go through, create the lab, the nodes, the link, and then actually start the lab. So this is a pretty basic topology. I believe it's just a Linux node, and I forget what the other one is. It's a very basic example. It's actually one that I followed from the blog post. And so let's go ahead and jump back over here. And you'll notice I have a new lab here called define lab, right? And it's in an on state. If we look in here, oh, it's a bridge or an external connector. So we have the external connector, and then we have a Linux PC. So that's why it was deployed so quickly, is because these are very lightweight resources. And it's called defined lab. And you might be like, okay, you mentioned that a couple times. Why is that important? If I go back here, you'll notice that in the resource CML2 lab, I actually have the title as defined lab, and then description hand-rolled lab. You can see I have an external connector labeled internet, and then I have a Alpine Linux node with the label Linux PC. And if I jump back here, you'll see that exactly that. So now let's go ahead and take a look at a quite, I would say, more advanced example. So we mentioned define mode, where we spell out all the resources, nodes, links, the lab itself. But let's go ahead and jump over here to the second way to configure a lab with Terraform and CML. And that is using the import mode. And this is where you actually import a template file, a YAML file. And you can import additional you can include additional variables, and we'll take a look at that here. So just like the last one, we mentioned CML2 as a required provider. We provide some initial values. You'll notice that I have, and I didn't mention this in the last example, but I have var.address, var.username, var.password. And like this basically just references variable names. And those variable names can be found in variables.tf. That's a separate file. Like I mentioned, this is not a Terraform 101 video, but I like to try to connect the dots when I can and when it makes sense. So you'll see variable address, variable username, variable password, some descriptions, and some default values. This is important because if you do not provide these values, so if you just reference the variable and not provide an address here, then it's going to obviously hit the default value. Where the secrets.tf vars file comes in that I keep referencing, that actually will fill in the blanks. So it will provide an address, a username, and a password. But like I mentioned, I'm not going to show that, but you can see here off to the left, secrets.tf vars. This kind of has, think of it as almost environment variables. But like I said, I don't want to dive too deep into it. So let's take a look at one big thing you'll notice is this file is not that big, right? 21 lines, and there's only one resource. It's the lifecycle resource. And so I have a new, you'll see here, a new attribute topology, and it references a template file. And the template file, as I mentioned, is a YAML file, and then I also provided an additional variable here called lab name equals Dan's lab. Here is that YAML file that describes the topology. And before you ask, no, I did not handwrite this. So this actually came from, if you go into CML And I'll actually use this as an example. If you go into CML and you go to the Simulate tab at the bottom, there's a Download Lab button, and you'll see there's a YAML file. And here it pretty much is. It basically describes the lab that you've built. So the way I like to look at it is, if you plan to use Terraform with CML, I would highly suggest building a lab that you see as like a base template, right? So if you have routers, two routers and a switch and maybe a firewall, and you could connect them all up however you like, and then download the lab. So that way you have all your links defined, you have all your nodes defined, and it's just easier to get started versus trying to build this YAML file from scratch. So that's what I basically did. I basically built a topology that I liked and downloaded it, moved some things around, just to try out some things. So for an example, there's a couple things I want to mention. So the links, they're pretty straightforward. The title, so I mentioned here lab name with a $sign and single curly braces. That's basically saying, hey, fill in a variable, right? So think of it as like a Jinja 2 template where you have to fill in variables with the double curly braces. Well, with Terraform, you can do that with single curly braces and the $sign. So if I go back to that main.tf file, I do define lab name equals Dan's lab. You could, do comma and type out more variables and put more variables, right? So if you have a base template and let's say you share that with others, you could say, okay, please provide these sort of variable names, and it will fill it in the template for you. So moving on, the links, pretty straightforward. Like I said, you don't want to do this by hand, I promise. I tried a little bit, and just things did not connect right. I got a bunch of errors. It just was not good. The nodes section. Now, this is important, obviously, with all the different types of options that you have, but we'll go over some of the kind of the starter options and the ones that I would say as a network engineer you're probably most interested in. So we have a configuration section, and this is basically the bootstrap, the startup configuration. So I actually defined this myself. I just did some basic things to enable SSH and a couple interfaces, and it works. I've tried it, and so I definitely plan to use this moving forward. And there might be some other bootstrap configuration items that you're used to doing in your lab. So let's say you want to set up a routing protocol or something to that effect. You definitely can do that by defining it in this configuration section. Some other things you'll see: CPU limit, image definition, all this stuff will be filled out for you. Label, so this is what it will look like in the lab. Obviously the label below the icon. Tags, we'll come back to that. Tags are very interesting. X and Y. So X and Y are actually where it's deployed, or where it shows up in the lab environment. So you can see here they're just showing above and below each other, right? But if you go to some of my other labs, right? I mean, look at this, right? Very, very different topology, at least from the way it looks, right? So X and Y, that's kind of cool to mess with. I actually did mess with that a bit to kind of like, okay, move this one node all the way to the left side of the screen, or move this node to the very bottom. So kind of neat to play with. Interfaces, we'll skip over that. That's pretty straightforward as well. And I'm saying it's pretty straightforward because I'm assuming that you are downloading a lab and editing it, right? So if you add all your interfaces and you move all the nodes to where you want them to be, like your X, your Y, the interfaces, a lot of this stuff will be filled out and you won't have to really edit it. So here, line 92 is actually another device, and you'll see its configuration. It's very similar to router 1, and this is the tag again. Like I said, we'll touch on that at the end, but this has a tag of router. And then the bridge, or the external connector, will be for what I'm calling the internet, or connection outside of the lab, and it has a tag of ext. And then lastly here, we have an unmanaged switch that acts like the WAN, that I'm labeling the WAN, and also has a tag of ext. So let me go ahead and get this started. I probably should have started before I went through that YAML file, but it takes about 3 minutes total. So let me go ahead and dive into CML2 import lab. I'm just going to go ahead and do I'm going to go ahead and just do apply, because I believe I showed you plan before. We'll go ahead and do apply real quick, just so we can get it started. Because like I said, it takes a little bit. And just to quickly show you, there's really not much, because like I showed, there's only one resource called CML2 lifecycle, and we feeded that template file. So we'll say yes. So it's going to start creating here. Like I said, it should take about 3 minutes or so, about 3 minutes, 20 seconds, I think, after I tried right before recording. So we'll let it do its thing. We'll actually jump over here just so you can see it in action. So here's our define lab. It's turned on. And then here's the Dan's lab, which you saw that we defined that lab name in the template. And here are all the nodes. So obviously it was very quick to create a lab, throw the nodes in the topology, but now it's starting up all the devices. And these are IOSV images, so that's why I said it takes about 3 minutes, but if we were using like something like CSRs or the Catalyst 8000, it might take a little longer just due to the resources I have. But one thing to note, and this is why I wanted to wait to touch on the tags, are the routers are booting up now, but the external connector and this unmanaged switch that we're calling the WAN have not booted up at all. So one really cool thing, and shout out to Ralph for this, is you can actually tag your resources to tell them what order to boot up in. And let me try to show you an example. So there's this staging, and I keep calling them attributes, and I know I'm probably getting it wrong, so I apologize if you're watching this, you're a Terraform expert. But essentially you're defining, in the staging section, you're defining the different stages and in the order they should start up based on tags. So you tag each of your resources. So I'll go back here, and we'll just look up tags. And you'll see, there's router, ext, and the ext stands for external. So if I go back to main.tf, you'll see it's a list. The router, any node that has the router tag will start up first, and then any one with ext will start up second. And if we go back to the documentation, and that's actually why you can see the router starting up first, and these ones, because these two nodes have the ext tag. And if you go back here to staging, that's an example. Let me see if I can find. I'm trying to find the actual documentation here. Right. So you can see staging defines in what sequence nodes are launched. So stages, you can have a list of strings. It's an ordered list of node tags, and it controls the node launch. Nodes currently not launched will be launched in the stage with the matching tag. Tags must match exactly. Now there is another value that you can put in there called, it's a true false, it's a Boolean value, start remaining. And I don't have this, but by default it's set to true. So basically any node without a tag is started after all the nodes with tags. However, you could do start remaining equals false, and any node that does not have a tag will not get started. So hopefully that made sense. But anyways, I think the staging aspect is really, really cool, because it allows you to break it up into, probably some of the more resource hungry devices you'll want to split up over multiple stages. So my example is probably pretty bad, because I don't think you'd want to start these resources, all the resource intense nodes at once, because it would take forever. So actually you probably want to do like router 1 and the WAN switch, and then router 2 and the internet external connector, as two separate stages. But you kind of get my point, though, right? You can start them up at different times. It doesn't just boot everything up at once. All right, so let's take a look at, because we have router 1, everything has a green check mark now. Let's go ahead, just open up a console. And you can see, if you look through the logs, you can see we're generated the SSH keys. And let's just go to edit config tab. So you can see that what I defined in that configuration file is here in the startup config. So the host name, the domain name, some loopbacks, or I'm sorry, the interfaces, loopback 0, and then some gigabit interfaces, line VTY, and then the crypto keygen command. So all that was, and it would definitely tell you like, hey, it didn't work out. Trust me, I had a couple typos in the beginning, and it did not, that startup config did not apply completely. So yeah, that's pretty much it. That's pretty much the concept there. Real quickly though, before we wrap up the video, I will show you how to remove the labs, because obviously it's cool to always get the labs spun up, but some point you're done labbing for the day and you need to spin down the resources. So I'm going to go back through backwards, and then that will kind of wrap it up. One other thing I want to mention, and I'm not diving into it, like I said, honestly thinking about it, probably should make a part 2, maybe even a part 3 to this video. But we have outputs. So Terraform has this idea of outputs. So you can spin up using a provider and the provider's resources. And then what you can do afterwards, after the fact, is based on the what's spun up at runtime, you can actually print out the results. So here, I printed out the different nodes and the interface names. So router 1, here are the interface names. Router 2, here's a list of the interface names. The WAN, and this is just an unmanaged switch, so that's why you see like generic port 0, 1, 2, 3, 4. And then here's some of the node IDs. Here are the 4 node IDs. So that was just me playing around with the different outputs. If you're interested, they are in this outputs.tf file, and you can see it's a bunch of looping and other probably more advanced topics if you're new to Terraform. But it would be interesting, if you want to check it out. So let's go ahead and it's actually called destroy these labs. So we'll go ahead and do Terraform destroy, and we'll use the var file again because that has all of our connection details. So just to show you, we have it's up and running. My lab is up and running. It's turned on. Everything's spun up. And now we are going to, actually, let me see if I can just show you. So now we're going to destroy it. So it's going to say, do you really want to do this? And it has all these little red minus symbols. And I'm going to say, yep. And then you'll see this disappear down here. There you go. So you can see that's destroyed. And let me actually destroy this other lab as well. The define node one here, or I'm sorry, the define lab right down here, the other one that's turned on. I'm going to destroy that one as well. So you can see this one has a little more output in what it's destroying, because this one is, we actually define the individual resources that make up the lab versus using a template file. So a little longer video than I expected, but I think I pretty much covered what I was hoping to cover. Just as a recap, and we'll take a look at the different main files real quick. There are 2 different ways to use Terraform to deploy CML. One is called define mode, where you're actually defining the individual resources. So think the nodes, the links, everything that makes up the CML lab. So that is the kind of more manual, verbose way, or and my recommended way is to use the import mode. And this import mode is you feed it a template file, which is a YAML file. You can also add specific template variables if you plan to share this out with others, or kind of make it a more reproducible thing. So this YAML file is kind of what you would feed into the template file function that you saw in main.tf. This file was not written by hand. I would highly recommend downloading a lab first and then kind of tweaking it from there. That just is the sensible thing to do, in my opinion. So that is it for this demo, and I would say short tutorial, but looks like we're running on 30 minutes. So thank you for sticking through this. And if you have any questions, feel free to drop a comment or message me on Twitter at DevNetDan. Thank you.